Okay, we're up to 3-1, day 2. Graphing, but we're talking about end behavior, x-intercepts, max and min. But I'm going to start with a sweeping generalization just to give you a little nudge so you can kind of have something to lock into as far as like sketching a graph. Some of your homework is going to ask you to sketch the graph with the following polynomial. And if you have some general ideas, it's really going to help you. So here we go. We got a linear equation, a quadratic. We got a cubic. We got this is called a quartic. It's to the 4th power. Now we're going to go over some rules when we get into the 5th power, 6th power. The book loves the 5th power, sometimes the 6th power, and that makes our job a lot harder because this is really tough to kind of see with perfection. I'll talk about that in a minute. Desmos really doesn't even indicate what's going on when you type these sort of functions in. So with all that being said, if I graph this, y-intercept 1 up to right 1, bing, 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 there it is. Now, stop right there. Let's go here. That is our good friend, parent function, Mr. Parabola. And I want you to notice something. I'm going to talk about this and bring it back to here. What's the highest power or the degree of this polynomial? It's a 2. Now the question is, how many bumps? I call it bumps. Sorry, bad penmanship there. The book's going to call it turning points. It's the same thing. It's where it curves, where it stops, goes down and then comes up. It goes up and comes down. Those are bumps. Bumps in the graph. And this has exactly 1 bump. Look at that. 1 less than the power. What's the highest power of x here? Well, there's a little sneaky 1 there. How many bumps do you see in a line? You have 0 bumps. Keep that in mind. Y equals x cubed. I showed you guys. Goes like this. It goes like this. Now this is a little hidden, but you can kind of see it. There's a bump in here, and then there's a bump here. So technically it might be a little bit more like that. And this would be a little bit more like that. Okay, if you went, so we can see there's a bump here and there's a bump here. So there's 2 turning points, 1 less than the highest power. Now this guy, we haven't talked about this much, but that would look, I'm just being really generic right now, something like this. This would probably be right on the origin. I'm just going for sweeping generalizations, but we got 1, 2, 3 different turning points. See that? 1 less. Now why is this so confusing? The bumps can be so minuscule. For example, if I graphed this, it might be like this, and then it would come up and like just have a little tiny bump like that. And if you go to Desmos, you don't even see that. You just won't. You might type this in and you'll think, oh, that Mr. Features is wrong. There's only like 3 bumps. That's because the units are so big that the Desmos can't even pick up on the bump. Just go by the rules. There'd be 4 bumps on this one. On this one, there'd be 5 bumps. Just keep that in mind. So, with all that being said, that's going to help us in our next little adventure. Keep that rule in mind. Okay, so this problem kind of looks intimidating. Once you are just initially introduced to it, it says, hey, look at this crazy looking polynomial and its table of values. Now I want to say something right now. On your homework, they're just going to say, make a table of values. They're not even going to give you this. So you're like, well, what numbers do I even plug in for x? Just stick with this program. Now on the sample problem on page 133 that I'm taking, they actually just give you the y's. So the question is, well, what if they just give me that sweeping generalization, make a table of values for this? We'll stick with these x values, just stick with it as a rule of thumb, and you're going to have to actually plug them in. And I know that's a pain, but I'm going to be a little bit lazy, and I'm just going to plug in x is 0 because that's the easiest one. That'd be 0 plus 0 plus 2. So my first really easy point would be 0, 2. And look at this graph here. I want to really talk about the instructions, it says graph sketch. Now, when you see the word sketch, they are not looking for perfection. They're looking for accuracy without perfection. So if I plot that point, you can see my units are 10, 20, 30, 40. That's because these numbers are going to get massive. And so I go 0, 2 is right about there. Might be a little too high, might be a little too low, but we're just sketching it. Now, on this sample problem, they just spoon feed you all this information. If they don't, believe it or not, you got to plug this in here, plug that in there, figure it out, your y. So they're taking a shortcut on this one. One of your homework problems, they're a little bit vicious and they don't give you all that information. So I'm just going to fill this in a second. Okay, so we're going to use information that I showed you during the pre-lesson in combination with these actual points. So with these actual points, I'm just going to plot them. -3, -11.5 would be maybe -3, -11.5 right in there. -2, 6 would be somewhere maybe here. And then we get -1, 4.5, which would be right about here. And of course, we got our 0, 2. And we got our 1, 4.5, which goes back up here. And then our 2, 6, which I'm going to put right here. Maybe I put this one a little higher, but they're supposed to kind of be matching, as you can see. And then 3, -11.5, which would be right about here. Now, something that's jumping out at me, I'm going to make my final thing red here. That's a 4. Remember, we said it looks like this in my previous, sample 1, the linear, then the quadratic, then the cubic, then the quartic, looks like a W. Well, this is negative, so it's going to take this guy and flip it, and now it looks like a really wonky letter M. So we know we have 1, 2, 3 bumps, and the outsides are going down and down. So I'm going to start with the outsides right here. I know this is going down. I know that's going down. So that's just taking care of this portion of it. The outsides are going down. Okay? We learned that in 3-1 day 1. But generally speaking, we know we got 1, 2, 3 bumps. Well, where could those be? Well, we can see right here. Again, my drawing's not going to be perfect, but 1 turns, 2 turns, 3 turns, and there it is. So again, it says sketch. Is my drawing perfect? No. Okay. Now we can really answer all of these questions. This question right here, degree odd or even. Well, that was easy. That's even. It's a 4. Leading coefficient, well, it's -0.5, so we know the leading coefficient's negative. That's what flipped the W, okay? And then the end behavior, we cannot really get this unless we know the rule works like this, going down both directions. So as X goes to the left, remember, you are riding the greatest ride of your life. If you go to the left, you're going to go like this and down. So -infinity. That's this one. But if your roller coaster goes to the right, try and go to the right, it's also going down. So both of my end behaviors are -infinity. So it seems like a lot, but piece by piece, not too bad. Okay. Okay. Last sample problem that fits into your pre-lesson. So to really make sense of this, I'm going to really explain this as best as I can. So they're going to give you problems like this where it says sketch the graph of the following polynomial. And it's a real mystery because it's like, well, what polynomial? You haven't even given me one. That's where you're going to have to really get out your magnifying glass and look at these clues. Now, let's think backwards, okay? So the question says identify the x-intercepts. So we know that x-intercepts are any places on the x-axis where the graph might go through that. Now, look at these first 2 clues right here, Oh, another thing I wanted to say in this pre-lesson, I kind of scanned these numbers. These numbers aren't massive. I don't like these decimals because we don't see that very often, but don't panic. I'm looking at all these numbers, and I know I don't have to go by tens or twos. I mean, my biggest number on the board here is a 4. The smallest number is a -4. So we can kind of fit it right in here, okay? So these are all ones. I just didn't label them. But look where it says identify the x-intercepts. Well, remember, guys, if I'm making a general truth here, see, that's positive between that x-intercept and that x-intercept. And then if it goes below the x-axis, that would be negative. Now look at the first clue. It says the polynomial is, the graph is positive between -infinity and -4. So if I go out -4, 1, 2, 3, 4, okay, that's giving me one of my x-intercepts. From -infinity just means it's coming in this way. It might be coming in steep, it might be coming in flat, but generally speaking, it's positive. In other words, it's above the x-axis right here. All right, let's stop right there. I didn't put an arrow on here because I'm wondering, is it going to come back? But the thing is, it's positive from that whole space. So I'm going to go ahead and throw an arrow there because it's above the x-axis forever. So if it starts coming down and goes below, I don't think that's going to happen. -1, 4, or excuse me, and it's also positive from -1 to 4. These are my x values. So from -1, whoops, I put it on -2, might be from -1, oh, slash back there, all the way to 4. 1, 2, 3, 4, you can see it's positive. So do I know, see, it says sketch the graph. See, I don't know if it goes up this high. I don't know if it goes this high. It could go like this. All I know is it's above the x-axis. So we're sketching it. So what if a student goes with this one, and another student goes with this one, and another student goes with this one? They're all correct. But I'm just going to stick with the middle one just because. All right. So there's that. It's above. And these are kind of spoon-feeding me the x-intercepts. So it's negative between -4 and -1. So between -4 and -1, I know it's going to be under. Now, how far under? I don't know. I'm just trying to make my graph look smooth. And then from 4 all the way to infinity. So that's telling me forever and ever that's going down. So there's a sketch of my graph. Now, what are my x-intercepts? Well, here's one, -4, 0. This one's -1, 0. And this one right here is 4, 0. So I get my x-intercepts and a sketch of my graph from the first two clues. Where is it positive? Where is it negative? And these are giving us our x-intercepts. It's just really fancy. Let me pause this a second. Okay, so the next thing they're going to ask us for is to identify the turning points. I call them bumps. We're going to use these clues right here to identify where they're at. Now you can see there's one here and there's one here. But how do we dig from this information to find out where those are exactly at? Well, it says it's decreasing from -infinity all the way to -2.67. So that's a different way of saying, all right, if I go from -infinity, which is over here, continue going to the right until I get there, it's going to go down until I get to that point right there, which is -2.67. Let me pause a second. I just wanted to make sure they didn't want the point. So they just want you to know that at x equals -2.67, that is where the turning point is going to happen. Where else is it going to happen? Well, it says it's increasing from -2.67 from here all the way to 2. Well, we can see that. So from -2.67 all the way to 2. So they're saying go out 2. So x is 2. Right at this point, x is 2 is where the turning point is. We could find it, but the book doesn't expect that of you yet. All right, so that finishes this pre-lesson. Again, when you first see it, it's kind of overwhelming. That's why I give you some example problems, so then it can kind of sink in a little bit better. Again, rewind this, listen to it again if anything threw you. Go for it.